Okay, let's do some word problems. So first, a curve passing 3, -1 has the property that the slope at point x, y is x plus 1. Find the equation of the curve. Okay, let's see why this actually gives us a differential equation. Here, the word slope, what does that mean? Derivative, right? So it's y prime. Okay? So y prime at a point x, y, x, y is what? X plus y. So that equation. This equation describes this sentence that I just underlined. The slope at point x, y is x plus y means exactly this. Okay? Furthermore, what does this mean? Yes?
Y of -1 equals 3.
No, this is the x value and that's the y value, right?
So y of 3 equals 1.
Yeah, so that this should be interpreted as y of 3 equals to -1. Okay, in other words, when x is 3, y has to satisfy -1. So this is a condition for the curve that has to satisfy in addition to this. So we all know that if you solve a first order differential equation, you're going to get parameter c, right? That undefined c will be specified after you solve this differential equation and impose this condition. Okay? So let's try to solve this. Right, what kind of differential equation is this? First order linear. How do you know that? This is y prime by itself. Right? Y by itself. They're all both power of 1, right? So any differential equation that has something times y prime and another thing times y and another function by x, right? You could have a function of x here, a function of x here, and a function of x there. With all of these powers being 1, those are called linear. Right? It's a first order linear differential equation. And for these, it's important to turn this into the standard form. So let's remember what the standard form is. Standard form of first order linear is y prime plus px y equals to qx, where the multiplier is e to the integral of px dx. So in order to use that, we have to first change this into y prime minus y equal to x. In this case, what's p of x? -1. It's a constant function, right? So we can compute m of x as e to the integral of -1 dx, which is e to the negative x. And what do you do after you find the multiplier? You multiply to the standard form, right? So I'm going to multiply to the standard form, which gives us e to the negative x y prime minus e to the negative x y equals to x times e to the negative x. So I multiply the multiplier to all of the terms. Yes?
Shouldn't the multiplier be negative e to the negative x?
No, it's always e to the integral of px, and this px itself is -1. I include this -1 here.
All right.
Yeah.
Good. Thank you.
Now, we know that the sole purpose of multiplier is to turn the left side into a product rule of something. And it's always this, it resembles this one, right? This entire thing turns into e to the negative x y prime equal to, and the right side is just that. And once you write the entire thing as a single prime, then you can integrate to get rid of this prime. So I'm integrating both sides by dx. Now let's try to do the integral. Okay, first of all, this prime and integration just cancels away. So on the left side, you just get e to the negative xy. That part is easy. Be careful, y is multiplied down here. It's not part of the exponent. All right, on the right side, what do I use to integrate this? No, you wouldn't be able to use substitution because, I mean, what would you substitute? At most, you'll say u equals to negative x, but the derivative is not going to do much. It's not going to absorb this x. So what's the proper method for integrating this? Integration by parts. So you have to integrate by parts. Or tabular integration. That's the one that I like. So let's do the tabular integration. Tabular integration. So you have to do plus minus d and integral, and by this LIPI thing, logarithms and then numbers. I don't know what it is, but yeah. So I just know that e to the negative x has to be integrated and x should be differentiated, right? So you differentiate x, gives you 1, differentiate 1, you get 0. And then if you integrate e to the negative x, that's negative e to the x. Integrate again, it's e to the negative x. The signs alternate. And then you do this. So going that way, I get negative x e to the negative x. Multiplying these, I get negative e to the negative x. And the last row has to be integrated, but if you multiply them, you get 0. When you integrate 0, you get c. Be careful, sometimes this is not 0 for some special integrals, and this last line does play a role, but when you chose a polynomial to differentiate and it hits 0, then this last row doesn't do much, okay? So this is what you get. And putting all of them, if I add all of these together on the right side, I get negative x e to the negative x, right? Plus negative e to the negative x plus c.
So the first one's always equal?
Hmm?
The first one's always on the other side of the equal sign? Oh wait, no.
Yeah, so this tabular integration, once you fill in the table, you always do like that, right? And then when you're done with everything, the last row, you multiply the last row, and you have to integrate the last row. That's how the tabular integration works, okay?
Can you do that with the integration by parts?
If you want integration by parts, let's try it. X e to the negative x dx. The way you calculate this using integration by parts is you set d. Okay, first, what's integration by parts? U dv equals to uv minus v du, right? So you have to pick something for u and something for dv, and in this case, you want to differentiate x, so you put u as x, so that du is dx, and you want to put e to the negative x dx as dv, so that you get v as the integral of this, which is negative e to the negative x. And then once you find out these counterparts, you can use this formula. uv is this times this, so it's negative x e to the negative x, minus v du. What is v du? This is v, and du is dx. So then you can continue and put minus of minus is plus, so you change that to plus. And the integral of e to the negative x is e to the negative x. Well, integral of e to the negative x is e to the negative x with the minus sign. So this minus appears when you integrate this. And therefore, you get the same exact answer as a tabular. So usually tabular gives you the answer much quickly and easily. So I like sticking with the tabular. Okay, so we're almost there. We're almost there. You can solve this for y by dividing by e to the negative x, right? So y is equal to, if I divide e to the negative x from here, that's gone. E to the negative x divided by e to the negative x is 1. And then finally c divided by e to the negative x. And so I divide everything, divide by e to the negative x, and I get this. Okay? So that's the curve. It's almost the curve that we want, except that it still doesn't pass through x equals to 3 and y equals to negative 1, right? So you should plug that in. X equals to 3, y equals to negative 1. Oh, by the way, before I do this, e to the negative x. Can't you raise this up, right?
E to the x.
As e to the x, right? So I can make it even simpler. So it's negative x minus 1 plus c e to the x. I raise this now. And then I know that when x is 3, y should be negative 1. Plug this in here, so you get negative 1 is negative 3 minus 1, plus c times e to the negative 3. No, positive 3, sorry. Positive 3. And then I get negative 1 cancels, and if I move the 3 to the other side, I get 3 equals to c times e to the 3. Dividing by e to the 3, I get c equals to 3 over e to the 3. And then I put that back in here, and my final answer is y equals to negative x minus 1 plus 3 e to the x over e to the 3. That's my final answer. Now, if you want to simplify this just a little more, this is not needed for credit, but I would also do division between the same base is same as subtraction of the exponents, right? So you can say this is same as 3 e to the x minus 3. I think that's the most simplest one. So on the exam, while I would give full credit to this, this will be the better version.